Welcome again to another introductory talk on 1M2M. I am Ken Figueiredo, and as usual, I will be speaking with Andreas Kraft about another one of 1M2M's common service functions. This talk will focus on notifications in IoT systems.
Hello, Ken, and thank you for hosting another one of our talks.
Good to be talking to you again. So our last talk focused on access control. You demonstrated that with a simple example of two streetlights and the permissions involved in allowing them to communicate with each other. So is notification a special form of communication?
Yes, you can think of it that way. Here's an example to show the difference. Let us say we have two sets of streetlights managed by different operators. They have not reached an agreement to allow the streetlights to access one another, but they do want to cooperate where the lighting from their systems overlaps. This might be at the boundary between two districts, for example. With a notification function, operator A can subscribe to an event that is generated by a streetlight or by a motion sensor, for example, managed by operator B. Operator A's light would switch on because it receives a status change directly instead of receiving a direct instruction from operator B.
Okay, so let's explore that with an illustration before we see it implemented in code.
Before we get to the Jupyter Notebook code, I need to explain two things. Here's our street lighting system again. You can see two neighboring lights, AE1 and AE2, that we want to interact with one another. I will explain how that works in my next slide. For now, note the addition of a notification receiver that is connected to the AE1 street light.
Okay, and just as a reminder, AE stands for application entity.
Yes, that's correct. The reason for showing this layout is that I use two Jupyter notebooks to demonstrate this scenario. One notebook deals with the communication between the streetlight application entities and the CSE. The second notebook contains the notification receiver or server. Its job is to display the messages it receives about the street lighting system.
That's fine. So you said you had two things to show us. What is the next one?
I will come to that in the next slide. Here's a diagram to show how I implemented the elements of our system using three Jupyter notebooks. The gray box on the left contains our usual Jupyter notebook. We use it to define and control application entities as they communicate with the CSE. The second box for the notification server, which appears as a second Jupyter notebook. To run through this exercise, the users will issue commands in one notebook. They will then have to switch to a second notebook to monitor the changes. The box on the far right represents our second streetlight, which plays only a passive role in the scenario.
Okay, so the box in the middle is our CSE that runs as usual in what we are calling the third notebook.
That's right. In the next slide, I will explain what to expect as we run through an operational scenario.
Okay, let's turn to that.
Here's our illustration with the addition of a set of information flows.
And the way to read these flows is from top to bottom, right?
Yes. The first step is to create a subscription resource, which a developer would use to monitor resources as they are created, updated, or more. It also carries configuration notifications are sent to a notification target, data about when and how.
Okay, so there's a lot going on here. If I can summarize, what you're saying is Streetlight 1 is talking to the digital twin of Streetlight 2 in the CSE in order to install a subscription to changes occurring in the digital twin of Streetlight 2. Have I got that right?
Yes, absolutely correct.
Okay, so does that mean that any other IoT device can also subscribe to be updated about changes in Streetlight 2 or AE2's status?
Yes, that is correct. but only as long access control allows it. In the Jupyter notebooks, I will change the content of the subscribe to command container for AE2 and show you how that changes appears on the notification server. That provides the foundation for any other IoT device or application to subscribe to changes in AE2.
Okay. Does this also make it easier to combine 1M2M and non-1M2M systems?
Yes. I said earlier that this scenario might arise if two system operators have not reached a business agreement over providing direct access to their systems. This might also be the case if one system operator is using a proprietary or closed technology. The notifications functions allow them to participate in larger and cross-silo solutions.
That's quite powerful. Can it also be used to reduce communication between the components of an IoT system?
Yes, of course. If the devices and nodes don't have to poll each other for status changes, but instead get notified only when there's a change and with all the necessary information, this can reduce the communication efforts and also the energy consumptions to a minimum.
That sounds great. Now, let's take a look at notifications in practice.
Okay. So, as usual, I already started our CSE in the notebook here, and I'm now initializing the notebook with the subscriptions. As you can see from the tree, basically we are starting where we finished last time. We have a streetlight AE1 with a light container. We have streetlight AE2 with a light container that receives the commands. And we have the access control streetlight ACP2 that allows the streetlight AE1 to access the light container, for example.
Okay, so we can think of this as the digital twin of our resources in the CSE that we talked about earlier.
Yes, exactly. So I will now start a notification server that we talked about before. This is another notebook, and similar to the CSE, I have to start the notebook here. So as you can see, when I execute the cell, the notification server is started and it's ready to receive notifications. Switch now back to the notifications, and I will create the subscription under the digital twin of AE2. You're familiar already with the sequence here. So first I send the subscription creation to the CSE to create it. But before this actually happened, the CSE sends a notification actively to the notification receiver on the other notebook and basically waits for a response that this is okay. Only then it creates a subscription and sends back a response as a result. The creation is very similar to all the other resource creations we already experienced. Here we have a couple of configuration settings. For example, the notification URI, which is actually the notebook here, or we have the content type and notification event type. That means when should actually this notification happen. If you scroll down a bit here in the notebook, these numbers are explained in the tables below. So for example, for the notification content type, we said, okay, please send us the whole resource. And here we are looking for the update of the resource, the deletion of a resource, or the creation or the deletion of direct child resources in our container for AE2.
Okay.
Scrolling up again and executing that cell. So the request has been sent and received, and we're seeing here the subscription that is being now installed under the light container 2 of the digital twin of AE2. I've now switched back to the notification server, and we see actually that notification has been received here. It looks like a normal HTTP request with a couple of header commands, but this one here is the content of the notification. It says verification request. It gives you the ID of the subscription, the internal ID in the CSE, and who actually sent it. That's a C streetlight AE1, so that's basically our notebook here. We're sending back a notification response, basically saying, okay, we're accepting that notification subscription creation.
Okay.
Switching back to our notebook, we are now sending with the next request. Actually, we are switching on the streetlight AE2. For simplicity, we're doing this from our streetlight, but this could be any other system, for example, another management system or a sensor device that reacts on movements on the street. Here, going back to the diagram, we are creating the content instance and we are receiving back a response, but also, in addition, we are receiving a notification about the change and have, of course, sending back a response to the CSE. The request is a create request, just a normal one for sending a creating a content instance with the command lights on. Executing that request, just scrolling down to see, yes, was successfully created. We can look at our resource tree. Here we see the content instance that has been created. If I now switch back to the notification server notebook, we see that we received a new request. Again, just an HTTP request, but this time we're receiving as a notification that includes the whole resource that just has been created, so that we get all the information necessary to react on it. So that, for example, if it slides on and with our scenario, for example, the neighboring streetlight, we see, hey, streetlight A2 was switched on, let's switch on as well. And of course, we have to send back a response. And that concludes the scenario.
Okay. Well, thank you very much for that explanation. We have covered quite a few concepts. You brought a lot together here in terms of notifications, digital twins, a way of making communications manageable and efficient for sustainability. If any viewers have got questions or they want more information, what is the best way to get in touch with you?
Yes, thank you for asking me that. First of all, you can comment to this video, of course, through the comment section on this YouTube channel, or you can reach out through Stack Overflow. The tag is 1M2M, where we can discuss any technical question in public.
Okay, thank you very much, and I look forward to our next talk, Andreas.
Thank you, Ken.